today, 15 minutes, I'm going to quickly talk about a new concept that we've got in the MSA world called the MSA Index. I'll then touch on some Queensland slaughter data, and then I'll have a look a bit further about what we can actually do on farm to improve eating quality. So let's jump into it. The MSA Index came about as we never had a true real-time estimate of whole carcass eating quality which we could relate back to the live animal. So we always had current measures that we knew impacted eating quality, but we could never actually say how much all of them together is moving your carcass. So we can say that rib fat, ossification, marble score, you need marbling to be up here, you need ossification to be down here, rib fat needs to be up here. You need to get to hot standard carcass weight as quickly as possible, but if you are going to add an additive in there, you need to know that's going to have an effect on eating quality. So it's a very complex recipe, and we needed a common language that we can use that is one single score. So we've come up with this score, which is a single finger to demonstrate all those carcass eating quality traits and how they reflect on farm, how they reflect to the carcass. So it is a weighted meat quality score for the entire carcass. So how is it created? Well, first we take all of our MSA inputs, which the MSA grader on plant will capture. There are also some inputs from the MSA and national vendor declarations. It then goes into the MSA model and is calculated for 39 cut by cook combinations. We then take it a step further and weight it by the cut proportion and come out with our MSA index score. Now, if that sounded incredibly scientific, this is basically the English version. We have a cow here. So every cut in the body eats differently, it looks differently, some of them taste differently, they're all different sizes, so we need to make sure every cut in the body is represented correctly. So, I don't think I've got a point, I do have a pointer, look at that. So we've got the chuck up the front here, we've got this tenderloin in the middle, obviously they've got different scores through the MSA model. They then get put by a weighted proportion, and we come out with the MSA index score. So let's have a look at some data. Oh no, we're not that far yet, sorry. Each carcass which passes MSA minimum requirements will receive an index. So if it passes meat colour, pH, rib fat, it will receive an index score. This is completely independent of company specifications on plant. So you will receive one if you pass MSA minimum requirements. The range is between 30 and 80, so by all means, if you're seeing scores in the 50s and 60s, they are not bad scores, they are within the average range. The higher the number, the better the potential eating quality, and thus the higher the number, the better. The purpose is to provide a standard benchmark, basically, over time of carcass eating quality, which we can relate back to the live animal. The MSA Index is available online via our new website called MyMSA. So all data post-2010 is online, so if you have kill data up there, it will be available online with your MSA registration number and password. If you don't have your passwords, please get in touch with us and we will find them for you. It's useful as an evaluation tool on farm and will give us the ability to look at seasonal, regional, all these different kind of impacts that we've never been able to look at before, and it's supported by our index calculator. Now this calculator is available on the MyMSA website, or there is a standalone version which you can get on your mobile phones if you have a smartphone. So now we can look at some data. So this is based on the Queensland kill data for 13-14. So we're looking at approximately 1.2 million carcasses here. And as we can see, on average, 54% of the kill is male. The average hot standard carcass weight was 278, almost 280 kilograms. Our average hump height was 85 millimetres. Os was 160. MSA marbling 300 or similar to an Osmeat 1. Rib fat was 7, and most importantly, our MSA index ranged in at 55.52, but there was a range there between 32 and 70. So when we plot that as a distribution chart, what we can see here is that we have that range between 35 and 75, and we can see that this chart has what we call a trimodal distribution, or what we're going to say here is it's got 3 humps. So we've got a hump that sits there at about 58 as an average index, we've got a hump that sits there at approximately 54, and we've got a smaller hump which is sitting right down in that base region. And we can then look at why we have these different humps. Well, firstly, We can split it up by HGP. So one of the things we notice here is that on average there is about a 5-point shift in eating quality by adding a HGP. Now, I'm not suggesting not to use HGPs in the industry. They're an integral part of the industry. But you need to know if you are falling out of company specifications by minimal margins, just think about all the other attributes that I've already mentioned: marbling, ossification score, and all of those. So 5-point eating quality difference, and on average the HGP treated animals had ossification scores slightly above those that were not treated. So then we can break it up by feed type and have a look at grass versus grain. Now, statistically, these two populations are very similar. I wouldn't actually say that there's too much difference between the two. The only thing I can comment on is that on average, grass ossification scores and hump heights were 2 points higher. However, we're not seeing a drastic difference between the two populations here. So grass are performing exactly like grain, grain are performing exactly like grass in Queensland. We can then look at the male versus female, and I absolutely love this chart because there is a perception out there that females are inferior when it comes to eating quality. And what you can see here in Queensland is that at low ossification scores, females are performing better. There are lovely blue colour sitting there above those males. So there's the lesson of the day. Feed her, treat her well, and don't stress her out, and she'll perform well. I think that's got more stuff for outside the beef industry myself. We can then take our data that one step further. So these are what we call percentile bands. Now, without going into too much information into the genetic side of things, we can use this to draw lines in the sand. So we can locate where our top 1% is, where our bottom 1% is, where our 50% is. So we can say that if you're in that lower percentile, we can move you up into the next percentile. We can then look at what the index scores are of these percentiles, figure out what their average attributes are, and then we can advise you how to move those animals up if you need to move them up. So top 50%, obviously 55.52 I mentioned before. So let's focus on the top 25%, the top 50%, and the bottom 25%. As you can see, we've got different index scores there. We've got a 58.52, 55.52, and 52.36. Now let's have a look at the attributes of these animals. Well, we've got an average marbling of 320 for 58.52, 300, 55.52, and 270. So as I mentioned before, as eating quality increases, marbling is increasing. We can then look at ossification score. So the difference is only 2 score steps away. So 150 to 170 between the top 25% and the bottom 25%. Rib fat, again, is increasing as the index is increasing. This one's a very interesting one because, as you can see, hot standard carcass weight is not higher in those higher animals, and we'll get on to a little bit more about that a little bit later when we have a look what the driving effects on the MSA Index are. And hump height, 70 to 85. Now, these scores are averages. They are not the be-all and end-all. They are not everything that there is to be. So you can have a 320 marble score, but then you might have a 180 ossification, but then you might have a lower hump. So you have to realise all these things interact differently with each other, and these are not the be-all and end-all scores. For that bottom 25% on hump height, the range was between 275 and 25. The range in the hump height of the top 25% was between 30 and 195. So this is our standalone calculator here, and I've just got an example of 2 different bodies. So we've got a HGP treated animal, average hot standard carcass weight of 280. We've got tropical breed content 100%, 200 hump height, ossification 160, marbling 450. And as you can see, that second body, I've removed the HGP and I've taken the hot standard carcass weight down, and we can still see that there is quite an effective difference between those 2 animals. Now, I'm not saying that's the only effect they'll have, but there is a significant difference there. Now let's talk a little bit about hump height. So when it comes to Bos indicus cattle, science tells us that there is more prevalence of what we call calpain and calpostatin gene expression. So calpain is the good guy. It's responsible for protein turnover in the live animal and thus aging in the carcass. And then we have calpostatin, which is the brake. So in Bos indicus cattle, we've got more of a gene expression of calpostatin, which means that the cross linkages in the meat is a little bit more extreme. So therefore, it makes the aging process that little bit slower. But through research for the University of Queensland, they've located the gene markers through what they call Snip Testing. Now, these two particular genes are in higher expression in these high-humped cattle. So it has been identified through this that the tenderness gene was positively correlated with hump height. So what does this mean in English? It means that greater hump height animals showed higher tenderness gene predictors and therefore consequently tougher meat. Now, these were all tested on 100% animals. So the basis of this information, it basically tells us in that 100% herd that we had there, the lower hump height animals actually had higher eating quality. So they were all 100% animals, but we had a range of a hump here and a hump here, and these lower hump height animals were eating better than the ones that were higher above. So that conversation around flatback cattle is if you are breeding flatback cattle, is that you are inadvertently improving eating quality. Another, just to bang on a little bit more about ossification scores. So here's another example. We've got an animal, roughly 280 kilograms, which was roughly the average, 100% tropical breed content. We've brought the hump down to 150. Marble score I've reduced and ossification sitting in there at 150. And as you can see from here, we've got a 53.89 index score. Now, if I just reduce my MSA index score, my ossification score by 1, have a look how my MSA index moves. We've gone from 53.89 to 54.56. If we reduce it one more score step, we've got 55.35. So we've just gone from an animal that was in the bottom 25% to an animal that is in the 50 percentile. So the crux of all of this, Bos Indicus cattle will meet MSA specifications and they will meet company specifications with adequate nutrition, backgrounding, genetics, farm management and preference for all the eating quality traits. They will succeed. These are the same rules apply to cattle all across the country. North, south, Bos Indicus, Bos Taurus, whatever they are, these same rules apply. And the last take-home message is this. We have this lovely document at the MLA Pavilion, and this is our tips and tools for the MSA Index. And in that we have this lovely table. And this table tells us what the major impacts on the MSA Index are. So basically you can see that by adding a HGP into your animals, there is a -5 impact on the index. But then we have other things like, apologise, I've gone too fast. MSA, that one wasn't a good button, I don't think. Sorry, it's back. Thank you. MSA marbling. So for every point you increase MSA marbling, you increase the MSA index by 0.15. For every 1 centimetre that you reduce hump height, you increase the MSA index by 0.7. So this table right here, if you are just falling out of company specifications, and I'm talking eating quality specifications here, make this part of your management decisions. Look at your grading results, find the animals, find out how they're tracking, read the grid fully to understand that there are additional requirements on top of MSA. Weigh up whether increasing the eating quality of your herd is beneficial to your bottom line. Can you get into that next category above? And know that using additives will have an impact on MSA eating quality. And lastly, come and talk to us. At MSA, we all love to talk and we'd all love to talk to you. So thank you.